One day we're gonna live in Paris. I promise.
Hello and welcome to the concepts video on inverse functions. So let's take a look at what functions do, the ones that we've already learned. So let's say we have a function called f, okay? And what we've learned so far is that function is kind of like, any function is kind of like a machine sort of thing. You give it a certain input, okay? Usually the input is denoted as an x or anything like that. Or let's say we input a certain value a, okay? So we input a certain value a and we put it into this function or this machine, and then we obtain an output, or the machine spits out an output. So in this case, in the case of x, when we put that in, we get out f of x, whatever that is. Okay, and then when we put in an a, we get out f of a, which actually, if a is a number or something like that, is an actual value, we get out another value called b. Okay, so now, this is a normal function, right? So we start off with our original function f. And now, let's say we want a function that goes backwards. So we could take our outputs, stick them into some other function, not necessarily this one or anything, but then we want to stick it into another function or another machine and get what we originally started with, which was our input, okay? So this would be called, this new box, or our new machine is called f to the, and it has this notation, it looks like f to the negative 1, but it's actually inverse of f, or f inverse, okay? That's what it's called. So this is called f inverse, okay? Alright, so basically here, what we can do is we kind of just stick in, so this now becomes our input side, okay? So let's say we stick in, I don't know, the b, okay, for the exact b from here. We're going to put that into our inverse function, okay? And then we get out an a, alright? So I know it's a little bit weird to conceptualize, but basically all our f inverse does is take any outputs that we had of our original f, any outputs, and it converts it back to the input, okay? So in a sense, inverse, what you can remember is inverse, that term, or that word kind of just means opposite, okay? And in this case, we're just moving, an inverse function takes us in the opposite direction that our original function did, okay? Alrighty, so essentially what we want to do is to swap our inputs and outputs of our original function, okay? So let's draw another kind of like schematic. Okay, so again, let's start with our original input, a. Okay, so let's say our input is going to be a, and we're inputting that into a function called f, alright? And then I'll just write, this is our original function f, okay? And then we get out our output, so output is now equal to b, or f of a, whichever you'd like to consider. And now we're going to take this output, okay, and we're going to make it the new input to a different function. So now the input for a different function is called b, okay, and we're inputting this into the inverse function now, okay, so this is the inverse of f, alrighty, and from this inverse function, we get an output of a. Output equal to a. So then see how this, we can kind of just go in a revolving circular kind of motion here, right? Through our kind of system. So what we see is that when we started with our original input, this guy right here, a, we stuck it into f, our original function, okay? We got an output of b, and then we put that result into the inverse function. And we got back to a. These are the same exact things, right? So what we can say is that, well, we took a, we put it into the function, the original function f, that's what that means, right? F of a is plugging our input a into f, and then we took that result, this result here, which was b, and we plugged that into our inverse function, f to the negative 1, kind of, it's not a power, but it's inverse of f, okay? So once we did this, we got back to our original starting point, a, right? And this would be the same kind of thing, but instead for b, what we would do is, let's say we started at b now, okay, so I'll just put a squiggly line under where we're going to start for this one. So if we start at b, this is our original input, okay, so let's say we start at b, we plug it into f inverse, okay, so plugging it into f inverse looks like this. We just kind of just follow the roadmap, right? So we're going to follow the arrows, we plug it into f inverse, and then we get some output, alright, and then we're going to plug that guy into our original kind of f, alrighty? So this one looks like this, and we get again, we get an output, again, from our original f of b. So we're back to where we started again. So this means the following, okay? So there's a difference between the two here because the order does matter, right? So on this left one, we plugged in a, was our original input. We plugged it into the original function and then plugged the result into the inverse. And then for this one, we started with b as our original input. We plugged it into the inverse and then the like kind of like the original function, okay? And we got back our b. So now we'll look at another twist or interpretation we can of our map that we drew before. So again, let's say our function f is here, okay? And you know how we've said input on this side, output on the right side, and all of that? Output. Okay, so another way we could say that is the range of all inputs. So this would be called the domain, right? We've learned about domain, and the other side would be called the range, okay? All the results you can get by plugging in your domain. So domain goes into f, this function here, right? And out comes the range, all right? So if we look at our inverse function, so f inverse, we can see that whatever we get here as our results, we just plug those exact same values from here into this function, right? So whatever we get here in that circle, we're going to plug into our inverse in order to get an output, right? Which brings us back to our domain. So for this, we could say, well, the range of f, the circled thing, right, is technically the domain of f inverse, because whatever we get as our output of f becomes the input of f inverse. Okay, and likewise, whatever comes out of our f inverse right here, whatever comes out is going to become, well, it's the range of f inverse, right? But then that range is also equal to the domain of our original. So it's kind of like again, it's a circular thing going on, right? So the domain of f is equal to the range of f inverse. And the range of f, range of normal f, is equal to the domain of f inverse. So they're kind of just swapped, right? Like I said, we're just swapping the inputs and the outputs, okay, to everything. Alrighty, so let me just write in a couple more things here, just to clarify, okay? So it's kind of divided like this, right? So this is on the top half of the line, that's everything going on with f, and on the bottom half, that's everything going on with f inverse. And the kind of like two lines just mean equal to, okay? Alrighty, so now let's work with a little bit of function notation. Okay, and function notation meaning that let's say we have f of x. Okay, that's like our original function, right? So the inverse of this would be called f inverse of x. Okay, not too shocking of a name there. And again, you pronounce it f inverse of x. Okay, don't say like f to the -1 because that implies that you're raising your function to the -1 power, which is not what's going on here, okay? So anyways, so this is how you pronounce it and everything, and so what this means is that let's say if f of a is equal to b, like we've seen before, right? Then f inverse of b, when you plug in the output, you get back to the input of our original function. Okay? And more generally, sometimes it's not even written with this like notation with the -1 there. So just in general, so we could say generally, if f of a is equal to b, then a function, and this means any function, okay, any function we see, it doesn't matter the name, it doesn't have to have this whole like -1 notation. So then a function, let's just say it's called g of x, okay, is an inverse of f if g of b is equal to a, okay? So here, the only difference here, because it made it more general, is that g, we have a different letter here. We don't necessarily have this f to the -1 kind of thing. So we don't have that notation specifically. So I'm just saying, like, if you see any function where it can take in outputs of f and give you back the input, then that function, whatever it's called, it doesn't matter the name, is an inverse of f. Okay?